This meeting is being recorded.
A very good evening, Virendra. Let us continue with our stereochemistry. Hope that you got an opportunity to go through the book authored by Professor P.S. Kalsison. We have much to study. Let us quickly move forward. We have to complete this organic chemistry revision by next Shabbat, means by next Friday, before entering into Saturday. So let us go through the material that you have provided. If molecule having asymmetric centers, cross line should be given to only asymmetric centers in a molecule. What is an asymmetric center? These are the Fisher projection rules. Arranging maximum number of carbons on the vertical line. In fact, these were taught to me by Professor Gumadi Samuel Moses sir while I was a BSc second year student, while I was studying my Bachelor of Science second year, that is in 1998. Professor Gumadi Samuel sir, Professor of Organic Chemistry, has taught me these Fisher projections, and he's a wonderful teacher. Gone are all the notebooks. Probably, I think in my BSc notebooks are still at home. Only I lost my MSc material. So I'm very hopeful, Virendra, that you are following the methods I'm teaching. That by placing different coaching materials at one place and standard books at one place, you have to prepare notes for each of these topics: stereochemistry, then heterocyclic compounds, then aromaticity, pericyclic reactions, photochemical reactions, SN1, SN2 reactions, then named reactions, natural products, all these things. That will help you to have a thorough understanding and good command over organic chemistry, and you should solve as many papers, old papers as possible. We are running short of time. We don't have much time. We'll stop exactly at 11:30 because if I close after 11:30, all the video is lost. All the information that we generated will be lost. Carbons, skeleton, unsymmetrical, highly oxidizable carbon group should be taken at the top of the vertical line. The group having maximum number of options, minimum number of hydrogens. Here, two oxygens, one oxygen, methane. The order is like this: methyl, CH2OH, aldehyde, carboxyl. Which group should be at the top? Groups attached to vertical line away from the observer. Groups attached to horizontal line near to the observer. You see, that is the beauty of stereochemistry. Stereochemistry, arrangement of atoms or groups of atoms in the space. All pressure projections are eclipsed. All pressure projections are eclipsed. What does eclipse means? Solar eclipse, lunar eclipse. Eclipsed configuration. See this between these two crosses. Theta is equal to 0. A, C, B, A, C, B. These are the eclipsed configuration. The angle between this particular group and this particular group will be 0. We know solar eclipse, we know lunar eclipse, like that. 90 degrees rotation in the plane of pressure gives enantiomer. Let us see this. A, B, C, D. Can we call this as an asymmetric center? You see, the four groups on this particular carbon are different: A, B, C, D. When we rotate it exactly by 90 degrees, what is happening? What is 90 degrees? Yes, this is 90 degrees. Rotate. D will come up, A will become side, and C will go down. So what is happening here? These are called enantiomers. going forward. 180 degrees in plane of rotation of fissure produces identical structures. You see, this is 90. First, let us go for 90. If it is 90, what will happen? D, C, A, B. Again, one more 90. B, B, C. This will become D, A. What is happening? Homomers. 90 degrees rotation in air leads to the formation of enantiomers. 180 degrees centigrade rotation in plane follows. Homomers. At chiral center of fissure, only two groups or atoms spatially exchange produces enantiomers or diastereomers. Enantiomer, diastereomer, a chiral center of fissure. At chiral center of fissure, only two groups or atoms spatial exchange produces enantiomers or diastereomers. Single chiral center molecule, enantiomer. Multiple chiral center molecule, diastereomer. You see, here we have A, B, C, D. What are we doing? Spatial exchange. C is exchanged with the D and D is exchanged with the C. Then spatial exchange of atoms in a molecule with single chiral center. This is the chiral center. Chiral centers are shown with star. Here you see two stars. What does this star? Means chiral center. If we have two chiral center and then exchange spatial exchange of atoms or group of atoms. You see, C is coming here, B is moved here, Z is moved here, Y is moved back here. What is happening? X, B, C. Yeah, single chiral center, enantiomer. Two chiral centers. Here the exchange is only between B and C. What is happening? Enantiomers are formed. Diastereomers are formed. For single chiral center, we have enantiomer. For two chiral centers, we have diastereomer. These two are diastereomers. Z and Y are unchanged. X and A are unchanged. Only a single atom is interchanged. Identical structures are produced. Spatial exchange of any three groups at the chiral centers produces identical. You see, A moved to C, C moved to B, B moved to D. Then what is happening? A is moved to C, C is moved to B, and B is only B is moved to A directly. B is moved to A far from behind. D is unchanged. D is unchanged. Identical structures. Such a transformation causes identical structures or homomers. So we have seen homomers, diastereomers, and also enantiomers. Mutual exchange of two pairs of chiral centers produces identical structure. This is the chiral center. Chiral centers are marked with star. A, B, C, D. What is happening? Two pairs are exchanged. A, C, C, A. B, D, D, ID. Mutual exchange of two pairs of chiral centers. Two pairs at chiral centers produces identical structure. You can see here, far away from observer, near the observer. These are near the observer. These are far away from the observer. So for rehearsal Fisher, then which we should continuously practice, otherwise we will lose track of things. We'll continue with wedge projections for tomorrow. Let me save this. Yes, these are the wedge projections. Beautiful examples are discussed. These are the fundamental molecules. Here we have two functional groups, OH and COH. So we'll talk of these beautiful amino acids, multiple chiral centers. Yeah, human projections. You see, we have completed stereochemistry at this stage, and we'll continue organic reagents, named reactions, molecular rearrangements tomorrow. Thank you for your kind attention.